Hi everyone, we are a team of 5 from Mepco Schlenk Engineering College, Vikas.T, and we are from third year EC. Myself, Arun, Vikas, and our teammates are Vaigundh, Prashanth, Srinivasan, and Ajith. So we are posing our idea on automatic VTOL irrigation system. So what is VTOL? VTOL is vertical takeoff and landing. Yes, absolutely, they are quadcopters. So we are interfacing the quadcopter and the irrigation system through GSM technology. So I will say what's our idea in brief. We are fitting the temperature and irrigation temperature and humidity sensors below the quadcopter. So when it moves to the field and sits in a particular area in a field, it will turn on the pipeline for the particular region, leaving the rest of the region aside. So when the particular region in the field is running out of water, and when its humidity level goes below the optimum level, it will turn on the motors. So without any delay, I will go to the block diagram and the LabVIEW file and show our irrigation system. So we have designed our irrigation system here. Let me run it. So at first I am configuring it in manual mode. So in manual mode, here are the two buttons, stop and start buttons here. So when you start it, the reservoir will start. The pump of the reservoir will start automatically. So we can see it, and similarly the pumps to the field will be starting when you start it. This is in manual mode. So what if we go to automatic mode? In automatic mode, we can also configure when the reservoir is half empty or empty, the pump will be on. So when the reservoir reaches the full tank, it will be automatically off, in off condition. So here we have configured the temperature and humidity levels as 35 and 25. So when it goes below 35 and 25, the tubes to the pipes to the irrigation field will automatically turn on. So here you can see I will configure temperature level as 33 and humidity level as 24. As I set the level as 24, the pump are automatically on. So we are currently developing our idea. So in future we will be configuring that single field will I will explain it. If the first row is short of water, so the first pipe is alone on and the rest is off. So in future we will do it, and I will show you the block diagram of how we have configured this. So this is the block diagram of it. So here we have set the humidity sensors level between 0 and 25, and considering the arid conditions and climatic conditions of our country India, we have created the temperature levels between 20 and 35. So here we have created date and time stamps, the time elapsed, and the tubes with some 8 tubes, and the reservoir levels are controlled here, and the automatic push buttons and automatic and manual mode selection buttons are placed here. So this is our irrigation system, and let me go to the quadcopter section. So this is the single axis quadcopter. So what's that? We are showing 2 motors only here. So I will run it. So this is the quadcopter is flying now. You can see the waveform charts, the response. Now I am going to shift the quadcopter to left. So I am shifting it left. Let me set it at around 20 degrees Celsius. 20 degree left. You can see the response here. It will take some time. So yeah, you have got the response. So it's around 1.89 seconds to response to 1.89 seconds, and you can see the percentage overshoot here. And in the waveform charts, I will turn on the turbulence levels now. If you turn on the turbulence level, you can see the cracky and wavy waveform chart. So you can also control the throttle levels of the quadcopter, and you can shift it right and left, or you can make it stable. You can reinitialize it, and in the PID gains you can change it. And the waveform chart plays a major role here because it gives out the angle values, set point values, the PID outputs, and motor 2 and motor 4, and its difference too. Here in the set point you configure it as plus 20, and you can see in angle it is around 22, and it slowly decreases and comes back to 20. So this is what the response time takes. So this is our project. In future we are planning to configure the connect the irrigation system and the quadcopter using GSM technologies, and configure the quadcopter alone and configure the quadcopter as autonomous using GPS technologies too. So this is our project. This will be of high scope in the future, as water scarcity is a major problem and availability of labors too is major problem nowadays. So this will solve the problem of availability of labors for the owners, so they will be enjoying a lot with this automatic systems. So thanks a lot.